This lesson is proudly brought to you by Kagiso Trust in partnership with the Limpopo Department of Education and Capricorn FM. Kagiso Trust, overcoming poverty.
It's 5 minutes after 5. Excuse me, Dinko Omar and Itubanda, the A-team, with you all the way up until 6 o'clock, of course. Rabela, we're going to be getting into hashtag Kagiso Radio Teacher, taking a look at mathematics term 1, Euclidean Geometry, Proportionality, and Similarity. Now, when I was in high school, I'm not going to lie, I haven't seen any of these. It is the first time. And now, of course, to carry the lesson for today, coming back again, came Mr. Marubini, and they're going to be with us up until 6 o'clock. If you're a grade 12 learner right now, please do make sure that you have all the necessary things with you right now. That could include something to scribble on, your calculator, and also let your friends know to tune into Capricorn FM. And also, if you've got any questions for Mr. Marubini regarding mathematics term 1, the number to hit us up on via WhatsApp is 082-654-2446. Welcome back again, sir. How are you doing?
I'm okay.
All right, you may proceed.
Today is the 25th of May, 2020. Welcome, all Capricorn FM listeners, especially grade 12 class of 2020. It is Mathematics Teacher Program. I am Marubini MF from Tengwe High School. May I also take this time to thank Limpopo Department of Education and Kagiso Trust for arranging these lessons for our learners. Today's topic is Euclidean Geometry. We are now on day 3 of Euclidean Geometry. In our first lesson, that was on the 16th of May, that was on Saturday, we revised Euclidean Geometry from grade 8 till grade 11. As you know that mathematics is a building block. Then, number 2, we also visited examination guidelines. That was on the 16th. Then on Monday the 20th, we discussed about Euclidean Geometry, grade 11 work. We also highlighted some of the steps to follow when one is solving riders. Today, I'm going to do the last part of Euclidean Geometry. It is based on grade 12 work. If I remind you about theorems, you know that there are theorems that their proofs are needed for examination purpose. I mentioned 4 theorems from grade 11 work, of which their proofs are very important for examination purpose. There are 2 that have remained, and these 2 theorems are coming from grade 12 work. If you want me to give you these theorems, number 1, it says, a line drawn parallel to one side of a triangle divides the other 2 sides proportionally. A line drawn parallel to one side of a triangle divides the other 2 sides proportionally. This is one of the theorems that you must make it a point that you must cite, since the proof is needed for examination purpose. Number 2, if the corresponding angles of 2 triangles are equal, then the corresponding sides are in proportion. The corresponding sides are in proportion. It says, if the corresponding angles of 2 triangles are equal, then the corresponding sides are in proportion. Although I've given you in this format, you can also get it in this way. They may say, equiangular triangles are similar. Equiangular triangles are similar. Make it a point that you master them. We have 6 theorems, as I told you, that we expect that in any paper that is going to be said, there should be what we call bookwork. In other words, we expect at least a theorem that you can prove. Remember, all theorems that you are supposed to prove, they are based on previous theorems that you've learned. You might have learned that in the previous grades or either the first theorem that you have learned. It is impossible for us to prove any theorem without the knowledge of the previous theorems. Make it a point that you master all of them. Since we are going to prove the first theorem, allow me just to highlight and give you some of the important skills, or rather important facts that you need to know for you to prove the first theorem in grade 12. Number one, you know that when you are supposed to get the area of a triangle, you always say half base multiplied by height. And if you still remember well, we've got almost 3 kinds of triangles that one can be able to get the area. The first one is when you are given acute angled triangle. Acute angled triangle. When I refer to acute angled triangle, I am referring to the triangles where the angle is less than 90 degrees. All the angles are less than 90 degrees. So we say that type of a triangle is acute angled triangle. Number 2, we also have another type of a triangle which we call it obtuse angled triangle. Obtuse angled triangle. In this type of a triangle, we've got one angle which is an obtuse angle. If you still remember, we are saying obtuse angle is the angle which is greater than 90 degrees. In other words, you need to know exactly how to get the area when you are given obtuse angle triangle. If you still remember, when you are supposed to construct height, always height will come out of a triangle. You won't draw it in the middle since it is impossible. As you know that height is always perpendicular to the base. Then number 3, we also have another triangle whereby we have 90 degrees. We have a triangle whereby we have 90 degrees. In other words, you can simply say half base multiplied by height. And you know that always when we refer to the height, height is always perpendicular to the base. Height is always perpendicular to the base. In other words, if I give you a triangle like this one, triangle ABC, where B is 90 degrees. If I give you triangle ABC, where angle B is 90 degrees. If one wants to calculate the area of this triangle, you know that height, it could be AB, and your base can be BC, or vice versa, as long as height and also the base are perpendicular. Then, don't forget, I said number 1, I was trying to remind you how to calculate the area when you are given triangles. The first one is an acute angled triangle. The second one is obtuse angled triangle. And the third one is right angled triangle. It's a triangle with 90 degrees. Then number 2, if you are given 2 triangles or that share the same vertex, triangles that share the same vertex, or if we say they've got common apex, you should always that whenever you are given triangle with the same apex, they've got the same height. What am I referring to? When you are given 2 triangles, where you find that there on top, they've met in a same point. That point, we call it a common vertex. As you know that when you talk about vertex, we are referring to the point where 2 lines are meeting. So in a triangle, we've got vertex. And in another triangle, we've got vertex. But when these 2 triangles, they've got the same point, we say they've got what we call the common vertex. Let me repeat this one. I'm saying when you are given triangles with common vertex, you must know that they've got the same height. When you are given two triangles with common vertex, you must know that they've got the same height. Number 3, you need to understand that if ever you are given two triangles between the two lines which are parallel, and those triangles, they've got the same base, those triangles, we say they are equal in area. When you are given two lines that are parallel, and you find two triangles between those two lines, and you find that those two triangles, they've got the same base, you can conclude to say, since they've got the same base, you say, they are also equal in area. Can you also try to reduce the converse of this one? Yes, of course. If you've got two triangles that are equal in area and they've got the same base between the two lines, then one can be able to conclude to say those two lines are parallel. Those two lines are parallel. So, from this one, we can also try to say if ever you are given two lines that are parallel and you find that they've got bases which are equal, if got the bases which are equal, when those two lines are found between the two lines, then you know that they are also equal in area. They are also equal in area. If you have checked well, in grade 12 work, they say grade 12 work is based on the following: ratio, proportion, and also similarity. Ratio, proportion, and also similarity. I think most of you might have heard about the word ratio. When we talk about ratio, we are comparing two types of quantities that are of the same type. And there are two ways of which one can be able to express ratio. You may say A is to B. That is the first way of which you can be able to express ratio. It's A is to B. Or you may say A over B. A over B. Let me repeat. We've got two ways of which one can be able to express ratio. You can say A is to B. A is to B. It's a first type where one can be able to express ratio. The second one, you can say A over B. A over B. That is the second way of which one can be able to express what we call ratio. Like I said before, when we talk about ratio, it means we are comparing two quantities of the same type. I may just give you a practical example where we use ratio. Number one, you might have heard when we do comparison of men towards women. For example, we may say 1 man is to 5 women. In other words, we are saying, in order to make sure that all women in the country are married, so each man must take 5 women. This is the type of ratio that we're referring to. Besides this one, if you still remember very well, sometimes when we make, in the Department of Health, when they're trying to make comparisons of the people who are sick, they may say, in a certain village, 2 is to 10 people are HIV positive. What does that mean? It means out of every 10 people, we are going to get 2 people who are HIV positive. In other words, in this way, that is what we call a ratio. That is also a ratio. Then, besides that example that I'm citing, you should also understand that when one is mixing a paint, you also need a ratio. You might have seen after some cars have been taken to the panel beaters, you would find that the colors are different. Why are they different? Because they failed to make a proper ratio. Remember, there are other colors that are coming from after we've mixed different colors so that we can produce another color. So it means we are also doing what we call a ratio. Then the last one, which is very common, I hope this one you have already done that one. When you are making a tea, you know how many spoons are you going to put in a cup. So that is also a ratio. It is two. We are putting 2 spoons or 1. It depends on you. So that is a type of ratio. Then let me repeat again. I said ratio. There are 2 ways to express ratio. You may say A is to B, or you say A over B. Number 2, when we talk about ratio, in other words, we are comparing 2 quantities. Like I said, example where I said 1:5, of which is the same as 1/5. Number 2, when you are mixing paint, you also do ratio. Or when you are making tea, you also do what we call ratio. But you need to understand the following. Whenever you are supposed to make a proportions, it means we've got 2 ratios, or we've got 2 ratios together. Or let me simply say, when we've got a ratio that is equal to another ratio, it forms a proportion. When we have a ratio that is equal to another ratio, it forms a proportion. Let me just give this illustration. If I give you this ratio, which is M is to R. M is to R is a ratio. Don't forget that this M is to R, you can also write it in a form of M over R. And then we say, this ratio, which is M is to R, is equal to the ratio, which is T is to P. T is to P. In other words, you can also write T is to P in a form of what? T over P. T over P. In other words here, we are saying M over R is equal to T over P. M over R is equal to T over P. Since we have equated 2 ratios, now we conclude that this is a proportion. It is a proportion. So make it a point that you master this one. Then, whenever you are given a ratio, remember, if ever you are given A, B, C, D, just like that, and then we say they form a proportion, it means you can be able to write that. You may say B over A and also C over B. Then you know that when you do cross multiplication, you know that it will be the mean it will be B. In other words, you know that when you have done that in geometric sequence, I hope you still remember this one. And we can say this is a continuous proportion. It's continuous. In other words, when we've got 2, 4, 8, 16, 32, it's just like that. It is a continuous proportion, because every time when you try to get a ratio, you will find that the ratio is always 2. So it means it is a continuous proportion. Then let me tell you some few characteristics of proportions. Few characteristics of proportions. In other words, I'm going to use letters here, but if you use even if you use numbers, you will still find that whatever I'm telling you here stands. For example, The first type of a proportion that one can think of is the first one where I said it's M over R is equals to T over P. M over R is equals to T over P. Let me just give you in terms numerically the other proportion that you can have. If I give you 1 over 2 is equals to 5 over 10, it's a proportion. 1 over 2 is equals to 5 over 10. In the same way, one can write it in the form of 1 is to 2 is equals to 5 is to 10. When you simplify, always you get in that fashion. And since you know that every time, whenever we put ratio, you must always put it in the simplest form. And it is always abstract. It is not associated with any symbol. It can be millimeter, it can be kilometer, it can be kg. So that's why we say it is an abstract. Can I remind you again? I said number one, I said the first proportion, M over R, is equal to T over P. Then you must know the following characteristics of proportions. Number two, you are allowed to cross multiply a proportion. You are allowed to cross multiply a proportion. I'm going to use the first one. It is M over R and T over P. In other words, the numerator of the first proportion and the denominator of the second proportion, they multiply each other. What am I going to get? I'm going to get M times P. It will be equal to R times T. For you to understand better, my learners, make it a point. When I tell you this proportion, you need to write it down so that you must not have any confusion. Then, the second one that I said, you are allowed to cross multiply a proportion. Let me also do this one numerically. Remember I said, numerically I said, it's 1 over 2 is equal to 5 over 10. 1 over 2 is equals to 5 over 10. When we cross multiply, I'm going to multiply 1 by 10, and the answer will give me 10. And I also multiply 2 by 5. The answer will still remain to be 10. That indicates that if both sides are equal, it means it stands. In other words, it is correct. Number one is the original one. I can't say anything about that one. The second one I said, you are allowed to multiply proportions. Number three, you are allowed to revert proportion. When I talk about reverting, I'm saying you can write them upside down. Upside down. In other words, the numerator is going to be the denominator. Denominator is going to be the numerator. Remember, where is it coming from? It is coming from M over R is equals to T over P. What am I going to do here? Then it will be R over M and also is equals to P over T. Can we check this one? It has been reverted. In other words, it is upside down. Then, number three, we are going to do proportion across after this.
All right. We are going to be getting into news headlines, followed by sports in detail. And of course, we will be coming back with Boma Rubini to continue the lesson for today.
It was the job interview of dreams. But just as my phone navigated me into a maze of Office Park turning circles, my data ran out. Round and round I go now. Forever.
Running out of data is hard. It's time for easy with the new MTN Everyday Gigs. Buy once and get 1 gig every day. Get 30 gigs for 30 days for just $4.99 or 7 gigs for 7 days for $1.49. Join MTN, recharge and dial *136*2# or download the MTN app. We're good together. Everywhere you go, MTN. T&Cs apply.
News headlines on Capricorn FM. In news making headlines, other schools in Tlanamudiseng village the Bloberg Loga municipality say they are anxious about the return of learners. Meanwhile, Educators Union of South Africa, which represents almost 30,000 teachers nationwide, is seeking to challenge the reopening of schools from June 1st in court. And a tavern owner in Mankweng outside Polokwane Sello, Ramudumani, says it is unfair that only liquor stores are permitted to operate during the level 3 lockdown from the 1st of June. Your final bulletin at 6 p.m.
Capricorn FM Sports, on and off the field. We've got you covered.
Let's wrap up your sports for Monday. South African boxing legend Gerrie Coetzee says it humbles him that another country would want to honor him, as his biopic will be produced in the United States. The making of the documentary of distinguished former heavyweight boxing champion known as a Boksburg Bomber will start in July in various locations here in South Africa before the American production team heads to Cleveland, Ohio. It was the same state of Ohio where Coetzee snatched the WBA belt from Michael Dokes back in 1983 after knocking the American clean out in the 10th round, becoming the first African boxer to fight for and win the WBA heavyweight belt. Now, the 65-year-old Cape Town-based Coetzee spoke on Power Sport on what the tribute means to him as a South African.
It really makes me feel very humble. Another country paying this tribute to me as a South African. I mean, I'm not an American. It's like South Africa flies in Americans to honor them as a boxer and make a movie of them. It just didn't happen, and it wouldn't happen. It makes me really humble that the Americans go to that extent. And, it's not all, it's real.
And moving on to football, following penning his signature on a new contract last week that will see him at Clorkop for another 4 years, Mamelodi Sundowns coach Pitso Mosimane has revealed he had offers from rival clubs in the Premier Soccer League. Musimane's new contract will see him beyond the June 30th as the Brazilian's head coach, but he has not disclosed the names of the teams that approached him in an attempt to lure him away from the Tshwane outfit. The 7-year stint at Sundowns saw the now 55-year-old winning 9 trophies, including 4 ABSA Premiership titles, and he has expressed how he wants to try and add another CAF Champions League winners medal to his collection, having been able to clinch it back in 2016. And lastly, going further afield, Andre Gomez says he feels honored to be an Everton player and the club are special for helping him and others during tough times. The Portuguese, who missed almost 3 months of football after breaking his ankle, credited the club, his friends and family for making his road to recovery easier. Gomez was stretched off at Goodison Park on November 3rd following a challenge from Tottenham forward Yeo-Min Son, which left the South Korean in tears. Everton have been granted planning permission to build a mental health facility called the People's Place, and Gomez is proud the club are aiming to help others who do not have a comparable support system, and admits that he misses football just like everyone else.
The Manchester game, for example, was kind of weird at the beginning because I didn't have the trauma, but it was like weird to go back, a huge welcome back from the fans. But at the same time, I was thinking the last time I played home was when I got injured. So it was in the memory, not the trauma, but was a mix of feeling of, okay, I'm back, but I felt good and I was trying to improve. Obviously, I want the football to come back. We are missing the football, but we have to understand.
I'm back with more on The Go Breakfast tomorrow morning. For more updates, follow us on Twitter at Capricorn FM News, and for Capricorn FM Sport, ne ndivusani moyo.
Keeping you up to date with the latest sports news. Capricorn FM Sports.
Time now is 26 minutes before it is 6 right here on Capricorn FM, Limpopo's hottest frequency. We are going to be continuing with...
I've got it,
I'm confused.
I've learned how to pronounce it.
Using me.
It's Euclidean.
No, I wanted
Euclidean.
The name of the teacher.
Euclidean Geometry, Proportionality and Similarity, brought to you by Mr. Marubin.
Okay. At least you're onto something. Also, do remember that this lesson is proudly brought to you by Kagiso Trust in partnership with the Limpopo Department of Education and Capricorn FM. Kagiso Trust, overcoming poverty. Over to you, Marubini.
Oh, thank you. I have already explained the ratio and also proportion. I was giving you the 5 characteristics of proportion before we can actually prove a theorem. If you still remember, I said M over R is equals to T over P. That is a proportion. Then the second one, I said you are allowed to cross multiply a proportion. You are allowed to multiply a proportion. In other words, you multiply M by P, then you get MP. It will be equal to RT. RT, in other words, you're multiplying R by T. What are you doing here? You are multiplying a denominator with a numerator. Denominator with a numerator. If you still remember, if I gave you this proportion which is numerical, 1 over 2 is equals to 5 over 10. I said 1 times 10, it will be 10. 2 times 5, it will also be 10. It stands. In other words, it is true for all proportions. Number 3, you are allowed to put the proportion upside down. In other words, the numerator is going to be the denominator is going to be the numerator. If I give you from the first one where we said M over R is equals to T over P, M over R is equals to T over P. Now you can write it in a form of what? R over M is equals to P over T. R over M is equals to P over T. I think this is going to make sense if one is writing what I'm telling you now. Then, number 4, you are allowed to do proportion across. In other words, you are doing proportion of the numerators and the proportion of the denominators. In the first ratio, you know that it is M over R, and M is a numerator, and T over P, T is a numerator. Now you are allowed to equate numerator together with the denominator. In other words, you are going to write M over T is equals to R over P. M over T is equals to R over P. That is proportion across. The last one, if ever you are given a diagram, you can just take a small portion over the whole side. A small portion over the whole side. I think it will stand to be true when you are also doing the next theorem. Before I continue, or I do problems in terms of this, allow me just to prove the first theorem. It says, a line drawn parallel to one side of a triangle divides the other two sides in the same proportion or proportionally. A line drawn parallel to one side of a triangle divides the other two sides in the same proportion. Suppose I give you the following triangle. Triangle ADE. Triangle ADE. And you are also given BC, which is parallel to DE. Remember, you should also define that B is on AD and C is on AE. B is on AD and C is on AE. So, if you check BC is parallel to DE, BC is parallel to DE. If I ask you, what is the given information? Number 1, remember, whenever you give us information, make it a point that you give us according to the diagram that has been drawn. Probably in examination, they're going to give you a diagram, which will make it easier. Then, if you check here, we are given triangle ADE. And with what? DE is parallel to BC. Triangle ADE. With what? DE is parallel to BC. And remember, B is on AD and C is on AE. I hope you remember that. Make it a point that you draw the diagram. It will tend to be meaningless if you are not drawing anything. Then, what are you supposed to prove? It says you are supposed to prove that those two lines, those two sides are in proportion. When they say in proportion, I hope you still remember the terminology. When they are in proportion, we are saying the ratios are equal. In other words here, what can we prove? You can also prove that AB over what? BD. AB over what? DB. It goes like that. So make it a point that you also master that one. Then, if the other side is the same as what? AC over CE. AC over CE. Then, what are you going to do here? You are going to construct perpendicular height. The height that will find it, which is perpendicular to the side AD, we will call it H1. And the height that is perpendicular to AE, we will call it H2. So what are we going to do here? It is a construction. It is a construction. Then what are we supposed to do here? You are supposed to take the triangles. You must make it a point that you've got the triangles with the same apex. Same apex, in other words, they've got common vertex. So, firstly, make it a point that you identify two triangles with same apex. And they probably, because when they've got the same apex, they'll be having the same height. Let me check here. The first triangle, it will be triangle ABC and triangle BDC. If we check, they've got a common vertex at C. They've got common vertex at C. What are you going to do here? You are going to say half base multiplied by height. And base in this regard, it will be AB multiplied by height, which will be H1. And again, you also half BD multiplied by height, and still it will be H1. Why have we done so? Because they've got a common vertex or same apex. Remember, we've got half and half. They will cancel each other. And if we check H1 and H1, they will cancel each other. And what are we going to remain with here? We are going to remain with AB over BD is equals to AC over CE. I hope you remember that one. Then, without forgetting, we should also go to the other side. In this side, we are drawing a line that will be perpendicular to AE. And this line that is perpendicular to AE, we are going to name it H2. We are naming it H2. What are we going to say here? We need to identify two triangles that will have the same apex and or common vertex at B. What are those two triangles? It will be triangle ABC and also triangle BCE. Triangle BCE, they've got common vertex at B. If you check them, then you are going to cancel everything. You're going to cancel half by half, H2 by H2, then you remain with what? You must remember, you remain with what? We remain with what? AC over CE. AC over CE. But if we check well, there are two triangles. If we check them, that is triangle BDC. Another triangle BEC. Can we check? If you check there, they've got the same base. Same base BC. Remember, what have I said about this? I said when we are given two triangles with the same base between the two parallel lines, they are equal in area. They are equal in area. After that, it means you are going to equate the area of those two triangles. Then you conclude to say now the proportion stands for AB over BD and AC over CE. This is bookwork. It's bookwork. You cannot manage to go to examination room without having mastered this theorem, because it will be suicidal. In other words, you may not pass examination. Make it a point that you do well, since these are the guaranteed marks in examination. If you know this, we know that it is much easier for you to pass. So before I do this, before I continue with the second theorem, let me just give you a practical example of some problems that we can be able to do. Let me, if you still remember, we talked about the characteristics of proportions. Let me give you this as a triangle. You are given triangle A, B, C. Triangle A, B, C, where you are given that D is on AB and E is on AC, such that DE is parallel to BC. From the theorem that we have proved, if you know that the line has been drawn parallel to one side of a triangle, you can be able to derive proportions. So what are going to what are you given here? You are given triangle ABC. Triangle ABC with D on AB and E on AC. And your DE is joined, where DE is parallel to BC. DE is parallel to BC. From this one, when we try to apply theorem, you are supposed to solve numerical value of x. Let me give you this one. AD is equals to x. DB is equals to 4. AE is equals to 9. EC is equals to 3. AD is equals to x. DB is equals to 4. AE is equals to 9. And EC is equals to 3. Which proportion are we going to use here? I think the first one is much easier, where we are going to say AB, AD over DB is equals to what? AE over EC. After this one, the reason that we are going to give, you are going to give us the lines which are parallel. In this regard, you are going to say DE is parallel to BC. DE is parallel to BC. DE is parallel to BC. Then after that, in the place of AD, you're going to put X. In the place of DB, you put 4. AE, you put 9. EC, you put 3. After that, when you manipulate, you cross multiply, you are going to get your answer to be 12. You will get your answer to be 12. So, what you need to understand when we do this type of work, make it a point that you understand the basics. Make it a point that you understand the basics. If you can be able to express them, it will be much easier for you. Let me go to the second theorem. The second theorem, we are doing what we call similarity. When we talk about similarity, the difference between the signs of similar and congruent. When we talk about the similar, so you must tilt them 90 degrees. Is then that you know that three lines that are vertical represents that the triangles on any object is similar. But there is there's difference between similarity and what we call congruent. When we say two things are congruent, we are saying they are equal in all respect. They are equal in all respect. Let me just give a simple practical example. When we have pair of identical twin, those pair of identical twin, we say they are congruent because the way you see at them, they look alike in all respect. You can't be able to differentiate between the two. So we say that pair of twin, we say they are congruent. What is the difference between congruent and similar? Similar, we can simply say they look alike, although we may be able to see the difference, but they look alike. Let me just give a simple illustration. Let's say a mother and daughter, they are not congruent, but they are similar. A mother and daughter, they are not congruent, they may be similar. A simple thing that you also understand, if I give you different sizes of circles, all circles are similar. Although they are not equal in terms of the size, but they appear in the same way. We say they are similar. But remember, a tricky part is, even the objects that are congruent, they are also similar. In other words, we can say all objects that are congruent, they are similar. But it is not everything that are congruent, that are similar, that are congruent. So make it a point that you can be able to differentiate that. For example, if I give you pair of rectangles, if they are not equal in terms of the sizes, we can simply conclude that they are similar, but they are not congruent. If I give you types of square, if they are different in terms of sizes, we can simply say they are similar, but they are not congruent. The last example that one can be able to understand, if you've got a photo that you want to enlarge, an enlarged photo and the original photo, they are similar, but they're not congruent because they are not equal in terms of the sizes. So that's why we say they are similar. What am I saying here? We must make it a point that you master all these theorem. What do you understand? This says, if two triangles are equiangular, then the corresponding sides of two triangles are in the same proportions, and hence the triangles are similar. If two triangles are equiangular, then the corresponding sides of the two triangles are in the same proportion, and hence the triangles are similar. What you need to understand here, you will find in the book or in the question paper, probably where they will give you two triangles which are congruent or equiangular rather. When we say equiangular, we are saying the angles are equal, although they are not of the same size, but the angles are equal. And intentionally, we are going to draw one triangle to be bigger than the other triangle. We are going to draw two triangles, whereby the other triangle, it will be bigger than the other one. Let me just give you a simple triangles that are going to use here. We may give you triangle ABC. Triangle ABC is a bigger triangle. And we also have triangle DEF. We also have triangle DEF. Remember, triangle ABC is bigger than triangle DEF. What are we going to do here? Firstly, let's try to get the given information. We're given that A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. So what are we supposed to prove? We are supposed to prove that AB over DE is equal to AC over DF and is equal to BC over EF. Then, when we start to prove here, you need to do construction. You are going to mark G on AB and H on AC, such that AG is equal to DE, AH is equal to DF. Let me repeat. You do construction, you mark G on AB, H on AC, whereby you join the line, and AG is equal to DE and AH is equal to DF. From here, your starting point is to prove congruency between triangle AGH and triangle DEF. After you shall have done so, I hope you remember that we've got the sides that are equal from construction. AG is equal to DE and angle A is equal to angle D as it was given in the question. And AH is equal to angle DEF rather. Then from here you can conclude triangle AGH is similar to triangle, is congruent to triangle DEF, and which will say side angle side. From here, we are going to name the angle AGH to be G1. And we say G1 is equal to angle B. Why? Because if you have checked well, we've been told that the angles were equal. From there, we can conclude that GH is equal to BC. From here, what you're going to do, you are going to apply the first theorem. So you finalize that one, and I hope you're going to get the answer. But before we can be able to finish here, there are some important work that we need to master. We need to give you some tips of how to answer questions. Like when you have proved that two triangles are similar, you should always name the triangles according to the sides and the angles which are equal. Then, skill number 1. When you are supposed to solve problems, read all the information given to the diagram before you answer any question. And you can be able to note from your diagram sheet there. For example, if they tell you that AB is a diameter, you know that always, if it is a diameter in a circle, you know that the angle that is going to be inscribed angle to be 90 degrees. It goes like that. Use a diagram and fill the information. And the angle that is not given, you may name that angle to be X and work from there. You make it a point that we check all the angles that are equal to the same angle. Then, number 3, if suppose you are struggling to answer some of the questions in a rider, what you need to do, make it a point that you also rotate your paper. You rotate your paper, probably you will be able to see the answer. And remember, often the information that is given in the previous questions, you may be requested to use them when you are answering the questions that follow. In other words, the previous questions, probably they are the leading questions towards the final answer or towards the last question, which may be a little bit difficult. Remember, you must make it a point that you keep on practicing. If I remind you what the athlete said, the more I practice, the more likelier I become. In other words, the more you give yourself time to work on the problems, you will make it a point you get solutions. And the last part, let me give you a homework. I'm giving you triangle PQR, and S is on PQ, and T is on PR. You are supposed to solve for the value of X. What is it? PS is 35, SQ is 15, PT is X, and PR is 40. In that triangle, you will be able to get the answer. Good luck when you prepare your Euclidean geometry, and you're going to enjoy. And I hope so. Thank you.
Thank you so much, Mr. Marubini there. What a beautiful lesson. I hope that the grade 12 learners did suck all the juice out of that one, probably to help you prepare should you find yourself in the examination room sometime soon. Okay? Myself and Idubana have to say goodbye. Get out of here. We'll be back again tomorrow.
This lesson was brought to you by Kagiso Trust in partnership with the Limpopo Department of Education and Capricorn FM. Kagiso Trust, overcoming poverty. Goodbye.
Progressive Talk is up next with